In this video, I'm performing partial fraction decomposition involving a repeated linear factor using the Heaviside method. So for this example, decomposing x plus 1 over x minus 1 squared, x plus 2. The first step is to assume the partial fraction form. So using the table, we can see that that repeated linear factor is going to give us a over x minus 1 plus b over x minus 1 squared. So we have to take that repeated factor and all of its lower powers as well. Then the distinct linear factor x plus 2 will also give us a plus c over x plus 2. So I'm going to start by finding the values of b and c using the Heaviside Cover-Up Method. So I start with that left-hand side expression, x plus 1 over x minus 1 squared, x plus 2. So to find the b, I need to cover up what's in the denominator of the b term, which is the x minus 1 squared. And I need to evaluate this at the value of x, where x minus 1 is equal to 0. So that means taking x is equal to 1. So substituting this into the expression, I get 2 over 3. Therefore, the value of b is 2/3. So now to find the value of c. So starting with the expression on the left-hand side, x plus 1 over x minus 1 squared, x plus 2. But this time covering up the factor from the denominator of the c, which is the x plus 2. And I need to evaluate this for the value of x, which relates to x plus 2 equals to 0. So substituting x is equal to minus 2. This gives me minus 1 over 9. Therefore c is equal to minus 1/9. So to find the a, I need to use differentiation. So I start by taking that full expression on the left-hand side, the x plus 1 over x minus 1 squared, x plus 2. And again, I'm going to cover up the term which relates to the a, which is the x minus 1. So I take the derivative of x plus 1 over x plus 2 and evaluate this where x minus 1 is equal to 0, x equals 1. So the derivative of x plus 1 over x plus 2 is equal to 1 over x plus 2 squared. And I evaluate this at x is equal to 1. So this gives me 1 over 3 squared, which is 1 over 9. Therefore a is equal to 1/9. So having found a, b and c, I can substitute these back into my assumed partial fraction form. This gives me x plus 1 over x minus 1 squared, x plus 2, is equal to 1/9 over x minus 1 plus 2/3 over x minus 1 squared minus 1/9 over x plus 2.